Welcome. Today we will learn about MAP sensor. MAP stands for Manifold Absolute Pressure. You can find this MAP sensor in the intake system of an IC engine, that is internal combustion engine. Usually MAP sensors are used in diesel engines. It is responsible for measuring air pressure in the intake manifold, and by using this ECU will calculate the AFR ratio.
A few moments later.
Now look at this block diagram. Here this part is intake system. We have air filter. Here we have MAP sensor which is mounted on the intake manifold. This is a reference 3-cylinder engine with fuel injectors and spark plug, and I have even considered O2 sensor. All these sensors are connected to ECU, that is engine control unit. This MAP sensor usually contains 3 wires. First one is power, either it is 5 volts or 12 volts. Next one is ground or reference voltage, usually 0 volts. And the third one is signal output. Usually it will be from 0 to 5 volts. Here if you look at MAP sensor, we have a hollow cylinder shape and a cuboid shape. This chamber will be vacuumed out, or it could be filled with the air whose pressure is known and it is calibrated. And in between these two parts we will have a membrane that is called strain gauge. Strain gauge is an electronic component whose resistance changes according to the amount of strain that it is subjected to. Basically what happens is, as the airflow increases in the manifold, there will be a vacuum created in this cylinder part, thus changing its shape. This deflection will be reflected in the output resistance. That is, let's take an example of 350 ohm strain gauge. Initially when the strain gauge was like this, it may be around 300 ohms, and as the deflection increases, the output resistance also increases. That is, it may go from 300 to 310, 320, maximum 345 or 350. This strain gauge usually will have 2 wires, and those 2 wires will be connected to Wheatstone bridge. If you remember, you would have learned this in your PU or 12th classes, and the output of the Wheatstone bridge will be in the voltage. ECU's function is to keep this Wheatstone always balanced, that is, it should balance the ratio of these resistors. Now let's understand this sequence. Here initially change in intake air pressure will lead to change in resistance, in turn will lead to change in voltage after Wheatstone bridge, and voltage and pressure are directly proportional to each other. That means as the voltage increases, pressure also increases, and we know pressure and density are directly proportional to each other via ideal gas equation, that is PV is equal to nRT. From that we will get to know amount of airflow, and in turn we will be able to calculate AFR ratios by using another input, that is O2 sensor, by measuring the amount of unburnt oxygen. By this we will be able to know accurately whether the engine is running in a rich condition or lean condition. By this ECU will adjust fuel and spark timing of an engine. Now let's learn about types of MAP sensor. First, I have grouped 2 types together based on the output of MAP. That is, first one is analog and second one is digital. If the MAP sensor output varies continuously with the time, it is called analog. In analog, we can see voltage variation, that is 0, 1, 2, 3, 4 and 5. When it comes to digital, we have only 2 levels, that is low or high, or it can be 0 or 1. In our case, low refers to 0 volts and high refers to 5 volts, and we are getting the output in the form of PWM signal, that is pulse width modulated signals, and according to the duty cycle of this signal we will get average voltage output. Now for simplicity, let's know PWM signals belong to digital type. The next type is turbo MAP. When it comes to forced induction engines, that is, if an engine is using turbocharger or a supercharger, it is considered as forced induction. Usually the output pressure will be around 10 kilopascal to 400 kilopascal, and here we can even use multiple MAP sensor, or we can use a combination of MAP sensor and MAP sensor. And here you can see I have written a term called speed density. Usually it is used by tuners. Speed density takes 3 inputs into consideration, such as map sensor input, intake air temperature input and the RPM input. By combining these 3, we will get an accurate AFR ratio. Thus, while tuning in the 3D maps or 2D map tables, we will be able to fill accurate AFR ratios and we will have a smoother curve and get maximum output of an engine. Now let's understand the symptoms of bad or faulty map sensor. If an issue with the map sensor arises, first we will get a warning in the dashboard in the form of MIL lamp, malfunction indication lamp or check engine light. And usually the car goes into limp mode, that is ECU will limit the maximum RPM of the car to let's say 3000 RPM or 3500 RPM. Next, we can even observe symptoms such as rough idling and erratic acceleration. We know if the ECM is not getting map sensor reading properly, it cannot calculate AFR ratios, right? So, engine may run in lean condition or rich condition, or it will lead to increased emissions or black smoke. Also, it will lead to lower performance from an engine. And one more thing I want to add, the difference between map and MAF sensor. In the MAF sensor, we are directly measuring the amount of airflow, but here in MAP sensor, first we are measuring the air pressure in the intake manifold, and after air pressure we are getting density, then the airflow, and then we are calculating AFR ratio. Even though the output of these two are similar, the method of getting AFR ratio is different. I hope you understood my explanation on MAP sensor. If you found this video to be informative or you learned something, please do like, subscribe to this channel. I will meet you in the next video. Bye bye.